All right, welcome to 1-1. We're going to start out talking about domain and range. So first thing you need to write is what is domain and what is range. So that's your X values, which are also known as your input, and your Y values, which is known as your output. So in this example, it asks what are the domain and range of the function y equals x squared minus 3, and it gives you the graph. By looking at the graph, it makes this slightly easier. So what we want to know is how far left and how far right does this function go. So if we look and we think about as this graph is going up, it is getting wider and wider to the left, and then it is getting wider and wider to the right. Slowly but surely, it's going to eventually get super wide. It's never going to quit getting wider and wider. So we say that the domain is all real numbers. Now we're going to talk about a couple of ways to write that because mathematicians are too lazy to actually write all real numbers. Okay? Something you won't see in your textbook, but Miss Reidner might use, is the super lazy way to just put an R symbol. So it's kind of like the paragraph symbol. So when I'm going to make that again, you make 2 lines, and then you make it a capital R. Okay? That's all that means is all real numbers, and that is one way to write it. We can use set builder notation to write a verbal description, or we could use interval notation where we use numbers and the infinity sign to say that same thing. So in this case, our domain is everything. So in set builder notation, that looks like x such that x is in between negative infinity and infinity. Okay. And then for range, or sorry, that was set builder. Let's also do interval notation. It's a little bit easier. We just use parentheses, negative infinity to infinity. Okay. The left is our minimum value, and the right is our maximum value. So let's look at that in terms of range. So notice for range, you always want to go bottom to top. So for domain, it's left to right. For range, it's bottom to top. Okay, so the very bottom of this blue graph here occurs right there. I need a thinner highlighter, but that's beside the point. So what is my y value right there? So if it helps you, label it 0, -3. Well, my y point is -3, sorry. And then how far up does it go? Well, it goes up forever. So in the words of Buzz Lightyear, it goes to infinity and beyond. So I am currently writing interval notation. Anytime interval notation has an infinity symbol, we put a parenthesis. If the point is included, meaning it's actually right there is a point on that graph at that position. There is a line. It doesn't have to just be a point. It could be a line. You're going to put a bracket to denote closed. Okay. So in set builder notation, we say that it's y such that y is greater than or equal to -3. So again, look at it, it's -3. It's all the numbers bigger than -3, so that's the same thing as saying greater than or equal to. At first this seems crazy, but eventually you do it so many times that it becomes easy. So keep practicing and we'll get it. Here's some more examples here where we're filling in the boxes. So if you want to take a moment, pause and see how many of those can you fill in with what is said. Now would be a great time to see if you understand it. If not, keep listening and I will keep going. All right, so we have all real numbers that are greater than or equal to 3 and less than 4. So think about a number line. Here's 3, here's 4. It's all the numbers in the middle. It's greater than or equal to 3. And it's less than or equal to 4. So that denotes closed. So 3 is the smallest value, 4 is the biggest value, and since both sides are closed, both sides are brackets. This one, all real numbers of x such that the numbers are greater than 3 and less than 4. Oh, greater than 3 and less than or equal to 4. So if the symbol that I did right here confused you, notice that the x value is greater than. Even though I drew a less than symbol, the open mouth is on the x, so you're saying that x is greater than 3. Okay. For the next one, all real numbers, I don't have enough space, so I'm going to shorten it. That are greater than or equal to 3 and less than 4. It's easier to write that sentence from the set builder notation than it is the interval notation, but either work because they mean the same thing. On this one, I look at set notation. They're both not equal to symbols. So that means that they're both going to be parentheses. And then for the next one, all real numbers greater than or equal to 3. So x such that x is greater than or equal to 3. For this one, I would not have actually written this part. Your textbook does, but I would just say x is less than or equal to 3. So, all real numbers that are less than or equal to 3. And to denote all real numbers, x such that they are all real is how I would write that. All right, the last one, problem to deal with domain and range before you can take a break. An air tanker flies over the forest, fires, and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of water the air tanker can drop in X seconds? So, when we are thinking about the amount of water, we can't drop negative amounts of water. So the water has to be greater than or equal to 0. So that's our domain. But then the maximum the tanker can drop is 8,000 gallons is what it holds, and it goes at 400 gallons per second. So what is 8,000 divided by 400? Well, that's 20. That's the max amount that it can hold. So 20 seconds before it runs out. So X has to be less than or equal to 20. So to write that as one statement, we start with 0. X is in the middle of that, and then 20 at the end. For the range, he can't hold more than 8,000 gallons. Also, he does not hold negative gallons. So Y must be between 0 and 8,000. I did make those equal to because they can have 8,000 and they can have 0.